Welcome back to Cloud 42. I'm James. Last week we got started installing a digital readout on my Grizzly benchtop lathe. If you haven't seen that video, you might want to go back and watch that first. This one will make a lot more sense if you've seen it. We went over the plan, disassembled the lathe, did some machining on the castings, and made a bracket to mount the X read head. This week we're going to make the bracket to mount the Z read head. We're going to make some modifications to the scales, put everything back together, and hopefully it'll work. Let's get started. The mount for the Z read head is a lot simpler than the one we made for X. We're just going to start here with a 1" by 1/4 inch piece of aluminum extrusion. I'm going to be drilling all the way through this, so I'll take the parallels out now that that's clamped in the vise. And we're going to be using a 3/8 inch aluminum specific end mill. This is carbide 3-flute with a polished surface specifically for cutting aluminum. This specific one is the YG1 Alu Power brand, and you can see I have it in a TTS tool holder for my G0704 mill, but it works just as well to drop into any other mill with an R8 collet. Now we'll just trim the other end to length, and we'll measure this with calipers. This requires a 12-inch caliper because we're over 8 inches. So the next step is going to be to put some holes in here. We'll use the edge finder to establish a center line and find the back edge. And then we'll come back with a drill. This is the tapping drill size for M4. And we'll put in a couple of holes here just to mount the read head. Now this is ultimately going to be on a tab, but for now it's in the middle of the part. And again, we're going to do as much machining on the part as we can before we mill it down so it's no longer rectangular and easy to hold on to. This is an M4 spiral flute tap, and we'll just drive this through and thread those holes. And again, the spiral flute tap pulls the chips up out of the hole, so it tends to work pretty well in aluminum, which can clog up other kinds of taps. Now we'll go ahead and get the other hole threaded here as well. And with that done, we can take the drill chuck out and bring back an end mill. This is a 1/4 inch 3-flute aluminum specific end mill, again in a TTS tool holder. I just grabbed this out of the CNC mill tooling drawer. And we're going to put the adjustment slots in the end here. Now this part is sticking out from the vise and it is a little bit flexible, so we'll just take it nice and easy. This is not a high precision part, so it doesn't really matter. We'll just carefully plunge through this and get the hole established, and then come back and side mill the slots. And with the 3-flute end mill, I have seen these things plug up with chips and chip weld and snap off really quickly in a CNC machine. In a manual mill here where you can feel what's happening, it's not as bad, but we'll still take this in a couple of depths over and back just to make sure we get a nice clean slot and don't have any mischief from the end mill. And we'll just repeat exactly the same process on the other end and get a slot there as well. Now I think that's all of the holes, so we can mill away the bulk of the material to bring this part to its final shape. We'll just deburr these holes and stand it up in the mill vise. Come back with the 3/8 inch end mill and mill out to leave the tab. Now this is not a precision part by any means, so we'll just touch off on the top and the side and zero the DRO and then just use it to drive to the final dimension. And since we're just cutting in aluminum and we have a nice sharp carbide end mill, we can just go ahead and push this thing. Because it's not supported out in the end, it's squeaking a little bit, but once we get into the meat of the cut, get it pushing hard and making a good chip, it runs nice and quiet. Square off the end there and then repeat from the other side. And that's it. That's the final shape of the part. Just needs a little bit of deburring and we can go start putting this thing together. This is the magnetic scale for the x-axis, and it's longer than we need, so I've marked it where it needs to be cut. Now all of these scales are marked here to show which side the actual magnetic scale is on, and I've transferred those marks up to the aluminum extrusion because we're going to pull out this strip before we cut it. and I want to be very, very certain we get the strip back in the right orientation so we can tell how the reed head has to be aligned. The caps are just attached here with a couple of M3 screws. We need to take those out and pull the cap off and then pull the stainless steel strip out before we cut it. They're a little bit sticky sometimes, so I find that a pair of needle nose pliers helps. You can just get hold of the edge and slide it right out. And then with the stainless steel strip out, it's just a matter of lining up the cut mark and we can cut it. In this case, this isn't even a metal cutting saw. This is just a carbide woodworking saw, and it will go right through the scale. You can see a few sparks get thrown when this goes through, and that's because there is some steel or some kind of ferromagnetic material behind the magnetic strip, probably just there for shielding. Once we get it cut, we need to go ahead and thread the round holes that are full length apart of the extrusion, but we need threads in the end so we can screw the cap on. And that's easily accomplished with a spiral flute tap and a cordless drill. And then we just need to cut the stainless steel strip to length. We'll slide it all the way in just to see how long it needs to be, and then flip it over and score it with a carbide scribe just to make a mark and see where it needs to be cut. And then it can easily be cut with a pair of ordinary scissors. These are just sewing scissors, don't tell my wife, and it goes right through it. It's just 4,000 stainless, so it's pretty simple. And then the cap just goes back on with the same M3 screws that came out of it. I'll go ahead and cut the other scale for the Z-axis and meet you over at the lathe. And wouldn't you know it, the moment I turned off the cameras, something interesting happened. Turns out that stainless steel strip is really thin and really sharp, and as I was pulling it out, it slipped and went right into my hand. Looks a lot worse than it really is, just a couple of scratches, a couple of band-aids cleaned it up, but this is one of the few times where I'm going to get comments telling me I should have been wearing gloves. I need to drill the cross holes in the scale so that I can mount it to the cross slide of the lathe. But before I do that, I want to match up the reed head using the marks on the scale and the sticker on the side of the head to make sure I have it in the correct orientation. It would be pretty upsetting to get it all drilled and then discover that it was backwards. Now, since I'm going to be drilling all the way through the scale, I need to take out the parallel. And we'll just zero up on this using an edge finder. I'll use the back surface of the scale and one end as my references. Now, looking at the cut end of the scale, there is just enough room to squeeze an M3 screw behind the magnetics and through the aluminum, as long as it's drilled very precisely in line with the groove on the side of the scale. Now that groove is a little bit narrower than the drill, so I want to start with an end mill just to clean that up and give me a flat spot where I can start the drill. Now, using an end mill and a drill chuck is usually not recommended, but this is a very small end mill. It's very sharp, the material is soft, and I got away with it. Now we'll come back with the drill. Now the drill is just ever so slightly larger than the end mill, so we'll start it real carefully just to make sure that it does center up in the flat spot that we made there. And it seems to be behaving itself pretty well, so we'll just sort of start pecking this through. Now it is a really deep hole and a really soft material. It's pretty gummy, so we'll just go slowly and add a little bit of lubricant as we get deeper in the hole just to keep the chips from sticking to the drill. The lubricant I'm using here is called A9, and I found it to be excellent for working in aluminum. Now we'll just check and make sure the hole didn't wander and it really did come out in the center of the groove, and it looks pretty good. So I think we'll go ahead and do the other two. Just use the same process. Create a flat spot with the end mill and then push the drill through, being careful not to clog the flutes and melt it all to the drill. Those are the holes. Those look pretty good, and assuming I did my math right, this should fit easily on the side of the cross slide. I just need to do a little bit of deburring, get this cleaned up, and it should be ready to go. Okay, I changed my mind already. We're not done. I would like to counterbore these so that the screw head will sit down into the scale and just reduce the amount that sticks out to run into the tailstock. So I'm just using an M3 counterbore here, and I set this all back up in the mill, use my DRO to come back to the original holes, and I'm just counterboring these down to the bottom of the groove, blowing out the chips with air and just doing this by eye. Once I've got all three of these counterbored and cleaned up to the bottom of the groove, I can test the fit with a screw. And it looks like the screw head is going to be just proud of the surface, but I don't really want to go any deeper and risk getting into the internals of the scale. Now we're really done. As I've been thinking about this project, I realized we don't need these end caps on the Y scale at all. We're not going to use them for mounting. We're going to use these holes that we drilled through the scale. So the end caps are really superfluous and they can go. And since the scale sticks out the front and the back of the cross slide, any extra length that we can take off of these is just going to improve the clearance. So we'll get rid of the metal end cap, and I have some 3D printed replacements that I made. These are printed on a resin 3D printer. I just sketched them up so they have the same geometry, plus those two little locating pins as the original cap, and so this should just snap right on the end. Got a little burr there and a little dent in the stainless steel strip that's interfering, but I can get that tucked under and it should just go right on and fit precisely. The dimensions from these resin printers are really quite astounding, especially given the price point. So that fits on there, and we'll put it back using some 3mm button head screws just so that we can countersink those screw heads below the surface. I've got little counter bores just molded into the part. So we can just run these down, snug them up, and that cap should clean up the end very nicely. Now really I'd like these to be black. I don't have any black resin. I have some ordered, and maybe I'll reprint them when it arrives. So that's one end. We can just do exactly the same thing on the other. And now we've taken, what, 1.5 inches or more off of the length of that scale. That is going to make a big difference. Nice. Now this Grizzly lathe has 3 gib adjustment screws, and behind each of those screws is a little piece of steel rod like this one. And the end of that rod bears on the side of the gib strip and presses it against the dovetail. Now the way they made this, the rods are square on the end, so you end up with just a tiny little edge or a tiny little point contact on the gib. And I would like to make that a nice flat contact, so we're going to put a 60-degree angle on the ends of these rods. And the quickest and easiest way I could think of to do that is in the D-bit grinder. So I've just got the rod here in a 4mm collet. I've turned the head to 60 degrees, and I've got a CBN wheel in here for grinding steel. And we'll just keep feeding it in until we get a nice flat grind all the way across. And that should be at precisely 60 degrees, so it should match the bevel on the side of the gib exactly. And it is just that quick and simple. Let's pop it out here and see how it looks. Looks good. I'll just take this over to the Scotch-Brite wheel and just soften up those edges a little bit. It's finally time to do some assembly. Here's the X reed head mounting bracket. I'm not really sure what happened. It looks like somebody might have nickel plated it. I don't know. It's been happening a lot in my shop recently. I've got the magnetic reed head here, and I can see the stripes on the side. I want to make sure that we get this oriented in the correct direction. And the reed head will just mount with a couple of M4 screws that came in the DRO kit. Get those snug down just to hold this in place. I'm just kind of holding it down against the bottom because there's a little bit of play in the screws, so I just kind of held it down so it would turn out parallel. And then this should be about ready to go on the machine. There is a hole here in the center for a stop screw, and I've got an M6 screw here that I'll just go ahead and put in. I can't adjust it right now because I don't know how much it needs to stick out, but once this is on the lathe, we can run this in and out and adjust so that the tailstock will come up and hit the screw first instead of hitting the scale. And that should be ready to go on the lathe. I've got the apron from the lathe here. We can go ahead and get the reed head mounted to it for the Z-axis. Here's the bracket we made, and lo and behold, the holes line up. I've got the reed head, and I gotta think about this for a minute and make sure I'm mounting this the correct direction. And of course, I've got the bracket on backwards. Putting it on this way, we'll position the reed head between the feed gears and the half nut, so if any oil drips from either one, it won't land on the reed head directly. Make sure we've got these stripes oriented in the correct direction, and go ahead and put in the screws. This is again just a couple of M4 screws to hold the reed head on the bracket. Now, there's no adjustment here, we just need to snug these down to hold the reed head in place. And then we can screw the bracket to the bottom of the apron. And I'm using washers here since this is soft material, the aluminum, and I don't want the screws to dig in. I want to retain the adjustability, and the washers will help keep the surface smooth so it'll slide easily. I get those snug down, and then I want to slide it all the way back to the furthest extent so that it will not be in the way when I try to actually mount this on the lathe. We'll just snug those lightly to hold it in place. And this should be about ready to go. You flip it over here into the orientation, it'll be on the lathe, and that looks to me like that'll work. Let's go put it together. Reassembling the lathe is exactly the opposite of taking it apart, and we're just going to oil everything with plenty of whey oil as it goes back together. Get the saddle on here. That seems to fit well, move nice and smooth. Now we've got a little clamp strip that goes under the back. We'll oil that up nice as well and put that underneath the back with the two screws and get that into position and tighten down. Still moves freely. We'll do the same thing with the clamp strip that goes under the front. And finally, install the carriage lock. Next up is the cross slide, and again, make sure that all these sliding surfaces have plenty of oil on them. And unlike last time you saw me take this apart, I'm going to remember to put the little dust shield in. It's a little bit of a game of Tetris here to get all these pieces to fit if you don't want to take the nut off, and I don't want to take the nut off. Got the Gibbs strip here, and I'm just checking the punch marks that I made in the end before I took it apart, and we'll oil this up and slide the Gibbs strip in. This is the same Gibbs strip that I trimmed down in a previous video to solve an alignment problem that came on this lathe from the factory. Now the Gibbs strip is actually held in place with these little push rods. These are the ones that we just beveled on the D-bit grinder, and I'll just go ahead and line these up the correct direction and slide them in the holes. The center one's a little bit longer than the others, so I need to make sure that I get that one in the right position. Then I'll just push them in with an Allen wrench, make sure they're seated, make sure they're rotated correctly. I think they'll rotate when I put the screws in anyway, but just make sure they're in correctly and go ahead and put the Gib adjustment screws in behind them. Now that center one sits into a slot milled in the Gib, so the Gib should now be trapped, and we can just come back and adjust the tension on all these and set the lock nuts. And that feels pretty good. Now it's time to mount the X reed head, and again this just goes in the two threaded holes that we put on the side of the saddle there. And we'll just go ahead and run the screws in. For now, there's no adjustment. We'll just make sure that it is all the way down at the bottom, just to make sure there's plenty of clearance. And we'll just snug that at the bottom out of the way and mount the scale. Now the scale, of course, just goes in with these 3 M3 screws through the holes that we cross-drilled. And we'll go ahead and just get a couple of these in to hold it in position. And then to make sure that the scale is absolutely level with the motion of the cross slide, we'll just use a 1, 2, 3 block to level it up. 1, 2, 3 block will just sit on the top of the cross slide and makes an easy way to measure this and make sure that it's level. And then we don't have to do any adjustment. We don't have to dial this thing in because we already know that the cross slide is moving correctly. I know that it's square and I know that it's machined properly. So if we line this up with the top of the cross slide, we shouldn't have to make any further adjustments. It should really be just that simple. I've got the front and the back anchored. I'll go ahead and check it in the center. I don't expect there to be any discrepancy here, but just in case the scale's bent a little bit, we'll press it against the 1, 2, 3 block and that'll anchor it into position. And now we've got the gib adjusted. We just need to adjust the reed head. So I'll put in the 0.5 millimeter shim that came with the DRO kit. We'll loosen these screws slightly. And then I'll just clamp the reed head against the shim, and that'll give us the 0.5 millimeter required clearance between the reed head and the scale. We'll just snug this down and then pull out the shim. It's a little hard to get hold of, but with an awl here we can get that out. And now that should be the correct clearance front to back, and there's really no sense in trying to dial it in. Should be perfect. Bring the apron back here. I'm going to slide that over the end of the lead screw, and we'll put the 2 screws in and anchor that down. Then with that in position, I think we're ready for the cross slide screw. Get that oiled up. We'll screw it in just to get it into position, and then push it back and put in the 2 screws that hold the crank frame on the front. Then to make sure that this is really aligned right, I'll bring it all the way to the front so that the nut is as far forward on the screw as it comes, and I'll loosen and retighten these screws just to make sure everything's in the correct position. And that's the lathe reassembled. Now, positioning the Z scale on the front of the lathe ended up being pretty tricky. What I ultimately did is I just held it roughly in position and then pressed the reed head in against it to hold it in place. And again, this is just so that it won't fall out and to give me an opportunity to kind of roughly figure out where it needs to go. Now, using the reed head and kind of knocking it up and down so the reed head's hitting the insides of the scale, I kind of figured out where it needed to be, got a rough measurement, and then made a couple of stacks of gauge blocks the same height to space the scale down from the underside of the ways. Now, this actually worked pretty well. It allowed me to get it in there at about the right height and absolutely level, and then I put it in place with a woodworking clamp, and then just came back with a punch and marked where the screw holes need to be. I don't have a real good angle with this hammer. I'll tap it a few times, do the same thing at the other end, and that'll give me the position for my screw holes to mount it. Now, it doesn't have to be perfect because there is a little bit of adjustment in these slots. Now I'll come back and drill these. This is the tapping drill size for M4. Now let's go ahead and drill these out on both ends, and then come back with an M4 tap. And again, I'm using that same spiral flute tap in the hopes that it'll pull most of the cast iron chips out of the hole, and I won't end up jamming the tap in here and installing it permanently in the lathe. And once I get these holes tapped at both ends, then I can just come back and mount the scale with a pair of M4 screws. And I'll start out by just putting those in the center of the slot and then adjust as needed from there by running the carriage back and forth and kind of looking around the sides with a mirror and trying to make sure that I do have it running centered. Now, to get the scale straight on the casting isn't machined or flat. I'm just using a dial indicator with a magnet off the front of the ways, which I assume is machined straight and flat. And I just went back and forth here for about 20 minutes with the scale on each end and in the middle, adjusting the jacking screws to try to get it straight and at the same height all the way across. And this is really tricky because you make an adjustment at one end and it causes it to flex in the middle. You make an adjustment at the other end and it flexes the other way. And so this is just trial and error. And once I got that level all the way across, I just used the same trick, put the shim in there, loosened up the bracket, pressed the reed head against the shim, and in theory, this should be perfect. I should have my perfect 0.5 millimeter space from end to end. And to be honest, I didn't even go back and check. I'm pretty sure it's good enough. I went ahead and mounted the readout to the wall here behind the lathe. I was going to mount it to the lathe, but the backsplash is pretty flexible and the back of the headstock is, again, a sheet metal electrical box, and it didn't seem very solid, so I opted to just put it on the wall back there. It also sets it back a little bit so it's out of the way of storing my chuck keys back here. So I have just plugged in the cables, and I did go through the programming procedure to set it up for the 1 micron X scale and the 5 micron Z scale, and it appears to be working. When I move the carriage away from the chuck, the numbers go positive. Move it towards the chuck, it goes negative. And when I move the move the cross slide away from the workpiece, the diameter readout that I have it set to is getting larger. When I move it in, it gets smaller. So let's do a quick sanity check of the accuracy. Got the world's cheapest dial indicator here. This is just a Harbor Freight special on a Noga mount. And let's do a quick check of the Z. So I'll bring this in, bring the indicator to 0, more or less. Okay, I'll call that 0, zero that out, and let's move it in 1 turn of the dial, which is 100 thousandths. Okay, that's 100 thousandths on the dial. And we're reading 100 thousandths and 2 10,000ths. So that is excellent. It means I got the multipliers correct. Now let's do the same thing here on the x-axis. I don't think I'm going to be able to get this where you can see it, but I'll settle for putting it where I can see it. Okay, run that into 0. And now I'll run it in 100 thousandths, 1 turn of the dial, which should read as 200 thousandths on the diameter. And that's 100 thou on the dial, and it's 203 tenths. I will absolutely take that. The other thing that I want to test here is just to make sure we don't have any kind of weird interference with the motor, because I've got a VFD on this machine, so I will go ahead, close these chuck jaws down so stuff won't be flapping around, and power this thing up and make sure the display is solid. That looks good to me. Of course, I'll need to use it for a while and make sure everything is working properly, but so far so good. I do need to do something with the cables. I have not figured out exactly how I want these to lay in. I think I probably want the X cable coming over the top and anchored about here. The Z cable, it's really not a problem to find a place for it to go. I just don't want it dragging around in my chip tray, so I need to kind of figure out how to route it so it'll lay down and roll up properly. And it shouldn't be a big deal, but I'll fiddle with it and I'll get that figured out. I think that's it. We did manage to get a DRO installed on here, and I can still bring the tailstock all the way up, and it doesn't actually hit the scale that's wedged in here because of that stop screw that we put in. So I think we are good to go. If you enjoyed this video, give it a thumbs up. Feel free to subscribe to the channel and leave me a comment. I'd like to know what you think. Thank you for watching.